Hi everyone, I am Boyan Xiao and this is my demonstration for the second lab for E542 class. In this lab, we are going to build a server router client topological model on AWS. And we have four topics to go through in this lab, and the whole idea is that we are going to create a network structure which has a server, a router, and a client, and we are gonna make them to communicate with each other, and we are gonna measure the network access with the iPerf3 tools on Linux virtual machines. And my development environment is I use the AWS account, the free tier, and I installed the virtual machines VYOS 1.3 and the Ubuntu 18.04 LTS. And I am going to demonstrate my project on the README file of this lab on my GitHub page. So let's go. So the very first step for this lab 2 is that we have to create VPC and EC2 instances on AWS. For the VPC part, we go to the VPC console on the AWS website, and we go to the Your VPCs tab on the very left sidebar, and we can see that this one is the VPC we are going to use for this lab. And I will show you the configurations for this one, and we can see that the IPv4 address are listed here. It's a subnet mask, and we disable the IPv6 address because we are gonna use that. We are not gonna use that. And then we are gonna create 4 subnets for this VPC we have created. And we go to a subnets tab on the very left sidebar, and we can see that the four subnets are listed here, and their IPv4 addresses are listed here. They are assigned from the 10.0.1.0/24 to 10.0.4.0. And we are gonna use these subnets afterwards. And then we are gonna get some the elastic IP addresses assigned by AWS. We go to the elastic IP tabs on the very left sidebar, and we can see that we have already requested 3 elastic IP addresses for the further use, and their IPv4 address are listed here. This is the public IPv4 addresses which can be accessed through the open internet, and we are gonna use them afterwards. And then we are gonna get some elastic IP addresses assigned by AWS. We go to the elastic IPs tab on the very left sidebar, and we can see that we have already requested three elastic IP addresses from AWS, and their IPv4 addresses are listed here, and these 3 are the public IPv4 addresses, which means that they can access by the open internet, and we'll use them afterwards. And we are gonna create some EC2 instances on AWS. And we go to the instances console on the AWS website, and we go to the instances tab. We can see from the list that we have already created three instances, and for the router we use the VYOS operating system, and the instance type is t3.small, and for the server and client we use the Ubuntu 18.04, and their instance type are the t2.micro. The very second step for the lab 2 is that we'll build a server router client model on AWS, and first we'll configure the routing relation for the EC2 instances. We can refer to this table to configure the network interfaces for the instances. And for the router instance, we'll configure its interface 0 to the SSH, and its interface 1 to the internal networks. And for the client server, we'll configure their interface 1 to the SSH, and their interface 0 to the internal networks. And for the internal networks, they are under the same subnet, and we'll use the subnet 2 for the internal networks, and its IP address is its subnet mask is the 10.0.2.0/24, and to use the SSH, we have to give the elastic IP addresses we just got to the instances, and we can access them from the open internet using the SSH. And then we can launch our instances from our local end using the SSH. And we'll open up 3 terminal windows from our local end, and we'll use the command here to launch the router instance, and it's up. And we will operate the our client, and it's up, and we'll access our server, and we can operate 3 of the instances we created from our local end using the SSH. If our instances are operating successfully, we can proceed to the next step. So the third step for Lab 2 is that we'll test the network connections for the model, and we'll set the routing rules. So our goal will be like this. If the client and server want to send the messages, they have to pass through the router, and the network traffic will be like this. The server to router to client, and the client to router to the server. So first, let's see what will happen if we did not set the routing rules for both the client and the server. And we'll first use the command TCP down on the router side to monitor all the traffic passing from the client and the server. So we input this command to the router side, and the monitoring is on. And then we'll ping the server from the client side and see if there is any traffic passing through the router. Let's go ping the server IP address. And we'll see that the client is sending the messages and to the server, but the router got nothing from both the client and the server side. So we can see that if we did not set the routing rules, the client and the server will communicate directly because they are under the same subnet. And then we are gonna set the routing rules for the client and the server. So before we set that, we can check the routing table for both the client and the server first. We go to the client and we input this command, and we'll see the routing table. There is no extra rules for the routing of the client, and also the server. And we'll also see there is no extra rule for the server. And then we'll set the routing rules to make them pass through the router to communicate with the server or the client. The command is listed here, and we'll input this command to the client and the server. Let's do the client first. I have already saved it in the command, and let's go. And we have set the new rules for the client, and we'll see the routing table again. And we can see that this rule shows up in the routing table. And we'll set the same rule for the server too. Yeah. And check the routing table again, and we'll see the new rules here. And then we'll ping again and see what will happen on the router side. 163. Yeah, and you'll see that there are traffic passing through the router, and it's from both the server to the client to the server first, and the server back to the client first. Then. And from this experiment, we can say that we have already built a network, and the network have the router ways that we send a message from the server, we pass through the router and to the client, and we send a message from the client, and the message will pass through the router and to the server. And we will say that the result match what we have expected from this this network structure. So you might argue with me that I just used a very rough way to measure the network traffic from the server to the client and also from the client to the server. So in the first step of the lab 2, we'll use a more precise way to measure the network traffics, and we'll use the tools named iPerf and iPerf3. So the when we install the iPerf and iPerf3, I will definitely say that we'll face a lot of errors and problems, and I have listed all the way to solve these errors and problems here, and we'll just skip this part because I have already installed the iPerf3 successfully on my machines. And let's go to measure our networks with the iPerf3. So the first step is that we have to launch the server. We use the command here, and we input it to the server side. And we can see that the server is on, and it's listening on the port number 5201. And we'll then to connect our client to the server, we use the command listed here, and we go to the client side, and we change this port number to the port number our server is using, is 5201. And we can see that the measurement has already started. And we can also see that there are a lot of traffic passing through the router because we have set the routing rules. And the measurement will last for 10 seconds, and we can see the results are listed here. So we have gone through the interval of 10 seconds, and we have transferred 808 kbytes data, and our bandwidth is the 662 kbits per second, and also it lists our jitter and also the loss. So this is the one measurement of the networks using the iPerf3. So next we'll simulate some the delay and the loss on the internet we face every day, and see what will happen if we do the measurement again. So first we'll add some delay to the client and the server, and we'll do the measurement again. So the delay command is like this, and we input it to the client side, and we stop the server first, and we'll do it on the server side. And then we'll do the iPerf3 again. First, we have to launch the server back, and we'll connect to the server from the client. So from the results, we can see that the interval remains the same, the 10 second. The transfer data size are the same, and the bandwidth has not changed, but the jitter can be higher. So we can say from the results that the delay can make the network less stable, and so the jitter can be higher. And then we are gonna try the loss. So we'll use the command like this to change the delay back to the 0, and we'll add the loss to 10%. And we'll try this on the client side, and we'll do the measurement again. Okay, so from the measurement, we can find that the interval, the transfer data side, the bandwidth are all the same, and because we put the delay down, the jitter can be also lower, and but the lost datagrams can become the 10%, and which is expected by us. And then we are gonna try the command here. We'll add a rate limit to the 100 mbit and the latency 1 millisecond and burst 9015. And before we do that, we have to delete the rules we have set. So we go to the client side to delete the rules, and the server side to delete the rules. And we input this new command to the client side and the server side. And I think actually we can only add these rules to the client side, and we delete the rules from the server side. Okay, and we'll measure the networks again. Use the command here. Launch the server and connect to the server. And from this time, we can see that the measurement can remain totally the same because we limit the rate to the 100 mbit, but our actual rate is much lower than that. So the limitation has not affected our bandwidth. So from this experiment, we can say that if we want to limit the rate, we have to know our actual rate, and we'll limit it to a lower bandwidth. And the last thing we have to do is that we change our bandwidth speed to the client side, and we can see that the AWS actually does not allow us to do this kind of stuff, because we have only the limited bandwidth resource. So this is not supported. So from above, we just saw what will happen if we add the delay and the loss on the client side. But what if we add all of this to the router? So we expect that the delay and the loss will also have the same affections on the whole traffic, because all of the traffic will pass through the router. So if the delay or loss are too high, the traffic will also be affected. So let's do the delay first. We go to the router side, and we add a delay rules to the router, but we have to note that because we use the ETH1 on the router to connect to the internal network, so we have to change the command the ETH0 to ETH1, so we can add the delay to the internal network's traffic. And we serve the iPerf3 again and see what will happen. Oh, we also have to open up the monitoring. You can see that they will pass through the router side. And we can see the result. Yeah, the interval, the transfer, and the bandwidth are all the same, but the jitter can be higher, and that is the same affections as we did when we add the delay to the client side. And then we'll add the we'll bring the delay back to 0. Yeah, we'll find the command, and we will bring the delay back to the 0 and the loss up to the 10%. And we'll do the measurement again. Also, we open up the monitoring to make sure that all the traffic will pass through the router. So we can see that from the measurement, we'll see that the interval, the transfer, the bandwidth are all the same, and the jitter are brought back, and but the loss can be 10%. So we can see that it's the same affections as we did on the client side. And the second step, and then the third step is that we'll change it to the well, first delete the rules, and we'll set a rate limitation on the router side. It's the same command, and we open up the monitoring, and we do the iperf3 again. And it's down, and I see we can see that all the same, they are all the same. So the third command has actually very limited affections on the traffic. So we can see that we can bring the conclusions that either we add the delay loss or the rate limitation on the server, on the client, or on the router end, the measurement can be the same, can be similar, because if we add them at the same time, the limitation of the network can be the bottleneck of the three of them, and we can see that the delay can bring down the stability of the networks, and the loss can affect the datagram's loss rate, and the rate limit will affect the bandwidth. Alright, so this is all I have done for the lab 2 for E542, and thank you so much for listening to my presentation. And if you have any concerns, please contact me at my email address. So see you on the next round.